Hello, today I'm talking with Paul Lynham, who is president of the institution and has been a member. Well, how long have you been a member, Paul?
I've been a fellow since 1994, which, how long is that? That's 20, God, I can't think,
28 years, yeah.
28 years. Yeah, 28 years.
A lot of things have
And
come and
of
gone.
course, I've been on the council since 1997. So that's 25 years at the end of this month.
And you've been president since?
I think it was 2018, so 4 years.
4 years.
Yeah.
That's
And
good.
I was vice president for 11 years before that.
So a long time working with the institution, moving things forward.
Yeah.
And a lot of changes, which I'm sure we will come to.
Yes.
So I suppose the first thing to ask is, how did you get into computing? What were you doing?
Well, I think even as when I was young, I was interested in electronics. And I remember my father getting a book out of the library on electronics, and we made a few things. Like he actually made an electric motor for me and magnets. And then I had a friend in school who had this book about how to make a computer. And it was a very basic one. It just had a series of lights which displayed in binary. But I suppose my real first step was when I was doing A-level biology, chemistry, and physics in school. We had a new biology teacher, and he'd worked for ICL. And he said, anybody interested in doing O-level computers? So I was one of about 12 people who put their hands up. And he then ran a class on computing, and quite a large part of that was programming. Of course, the school didn't have a computer. So what we did, the first language we learned was Cecil, which was a language written for school children. It's like an assembler. So it'd be a load accumulator number 1 or whatever, those type of instructions. And we had to write out our code on programming sheets. And they were sent off to a local computer center where they were a data entry clerk would type them in. Then at some point the program would be run with the punch cards, and then we get a printout with our punch cards returned to the school, ready for the lesson in a week's time. So we'd see our printouts, and after we did Cecil, we did Fortran. And typically in those days, the compilers wouldn't stop at the first error. So you left off one semicolon and you'd get about 120 errors. You'd get this printout and you'd see it got to line about 12 or something like that. And then you'd have error,
Yes.
And we'd be sent those with our punch card. So that, I suppose that's where I really got and that was in 1976. Yeah, and from then on, I went to Aberystwyth to study agriculture, and they had a North Star Horizon there, which was a terminal that was linked to Janet, which is a joint academic network. So you could link up with computers not only in Aberystwyth, Swansea, Cardiff, and so on and so forth. And that did have some basic software which I played about with. And I suppose that was the first time I'd actually personally interacted with a computer, because, as I said, when I learned programming, it was programming sheets sent off and run on a mainframe. And funny enough, we went to Cardiff University when I was in the sixth form to see what a computer looked like, because we you'd see them on films and so on, but we went down to Cardiff University and it was amazing. Massive air conditioned rooms, tape drives on the wall. The hard disk was the size of a dustbin, and you'd have to screw in the hard disk. And it was amazing speaking to the students, because even the ones who were studying computing, they said, we only get 2 hours online each week. So they had to do the same as what we had with most of their jobs. They had to be done offline, and they were put into a job control language and then run at whenever it was convenient.
Yeah.
And it's strange to think how computing has changed in those 40 odd years, from being something that you'd very rarely interact with a computer online. Most of the interaction would be offline.
Yeah, that's funny, Paul, because I came from the same sort of environment, doing my own electronics, the local college with their dumb terminals connected up to County Hall, who had, I think it was something like a Wang or something like that.
Yes.
And literally, I think we had 4 terminals in the computer room, but of course they were just dumb terminals connected to Chichester.
Yes.
And yes, so the rest of the time it was coding forms, sending it off. So it's very parallel
Yes.
routes. So I suppose from then, I think you've already spoken about doing your degree in agriculture, but did you do a computing degree as well, or did you just sort of
No,
progress into the profession?
no, but the stuff we did was we did quite a lot of maths and statistics, because when you're doing experiments, say you're growing a crop of wheat, and at the time the big thing there was lodging, where if wheat grows too tall, it falls over in the rain and the wind and is difficult to harvest. So they were looking at varieties of dwarf wheat. They were using different hormones, plant hormones like auxins and so on. So if you did experiments, you'd have to know how to work out if what you did had any significant effect. So we did things like the chi-squared test, and we'd have to work out the significances and so on and so forth. So there was a hell of a lot of maths involved. And not only that, I think the most maths we did was in economics, because we did banking exercises. A lot of the farm management side was looking how to profitably run a farming enterprise. So, not only did we learn how to do profit and loss and balance sheets to show net worth and so on, but we also had to do gross margins, and then we had to do cash flows. And at the end of I think it was one of the end of the third year. Yeah, it was the third year. We had this massive banking exercise where we had to do a cash flow for 5 years, which in reality is nonsense, because after the first year, they quite often way out. But of course, again, we didn't have computers, so we had to have these massive Barclays Bank cash flow sheets and do everything in pencil, because if you didn't sum up at the bottom and across, you knew you'd done something wrong. So you'd have to go with your rubber and rub out the pencil. But yeah, I think that course, and we did a lot of engineering with agriculture engineering. We did coefficiencies. We did stresses, we did designs of buildings, U values, R values, ventilation of farm buildings to stop, cattle having pneumonia. So we did a massive amount of calculations. So that really also interested me.
Yeah, this is
So
it.
it was sort of, not only was it was sort of mathematical, but it was technological, and that really gave me an interest in that field.
Yes, and I think also now, and I don't know what your feelings are on this, is that a lot of computing people are coming in now from computing courses, but without understanding. They're having to learn the businesses when they get to the job, whereas you were learning the business before you got to use the computer as a tool.
Indeed. And when I came across a computer that had a spreadsheet, I thought it was VisiCalc on an Apple II computer. And I thought, oh, if I only had this a few years ago when I was doing the banking exercise.
Yes, the spreadsheet has an awful lot to, how should I say, it should have been around about 10 years earlier, in my opinion.
Yes.
It would have helped
Yeah.
us all. So, so have you actually got a degree in computing? Is it all in agriculture?
I've got a degree in agricultural management and a master's degree in computing, because what I did is while I was lecturing, I started off lecturing in agriculture and was asked to teach computing to a YTS group. I was at the time I was teaching down in Hampshire College of Agriculture, and the head of agriculture called me in. He said, "I want you to teach computing to the YTS agricultural group." And I said, "Well, why me?" And he said, "Because you're the most qualified person in the college." And I said, "I've only got an O level in computers." He said, "Well, you've got an O level more than anybody else."
This is it. It's one of those industries where I think when I was there, the only way in was basically like local government or banking, because they were the only routes you could get into computing, whereas now it's just opened up so much.
Yeah. So what I did, I mean, I learned a lot about programming from teaching, but eventually I decided to do a master's degree, and I was lucky that I could do it part-time over 3 years. So I did it on a Wednesday from 1 o'clock in the afternoon till 9 o'clock at night. And it was lectures for the first 2 years, and the third year then we had to do a dissertation, and I had again, I learned a hell of a lot, because I did a sort of AI system into how to diagnose infertility in dairy cattle. And luckily there was only two experts in the UK on this subject, and one of them lived in Llanelli, which is about an hour and a half's drive down the M4 towards West Wales. So I think every Saturday afternoon I used to go down there and talk to this vet about how do you do this and how do you do that, and then try to get the program to do it.
Yeah, wonderful. So what was your first job? I'll probably say, well, first job in or out of computing, and your first job in computing.
Well, my first job was before I went to agricultural college. I did a year working on a farm down in West Wales, near Haverfordwest, on a mainly dairy farm, but they also grew cereals and they kept beef cattle as well. So it was again, I learned a hell of a lot from that. And then after I finished college, I went to work on a farm in Denmark. And when I came back from that job, I seen a job for a lecturer in agriculture, and I applied for it. And that's what sort of got me into teaching IT, because I moved over time. I moved from teaching agriculture to more and more teaching IT. And during the 1980s, I decided then to write my own agricultural software. And in the late 80s, I set up a company selling software. So I suppose that was my first real job, non-teaching job in IT.
Yeah, and I would imagine in those days, software in agriculture was few and far between.
I was one of 5 companies in the UK selling agricultural software. So
Yeah,
it was sort of cutting edge at that time, and most farmers hadn't even seen the computer. They didn't realize what it could do, and I always compare it to the people trying to sell tractors when they first came out, because farmers obviously had been using horses to do a lot of their work. And somebody came along and said, well, look, there's this machine. Instead of you ploughing an acre a day, you can plough 20, 30 acres a day with a tractor. And you know, the horse needs a rest. This tractor doesn't need a rest. You know,
Yes.
you've got to feed hay and oats to the horse, so it's taking up some of the stuff you're producing. Whereas this runs on TVO or diesel or whatever. So I suppose there was a lot of parallels between farmers taking up tractors, which they did very quickly, and the same in reality happened with computing. But I was at that first sort of wave, and sometimes it was difficult to persuade people. Other farmers, they wanted it straight away.
Yeah, I remember on the farm I lived, and we, again, a dairy we had there, and they were the first adopters, because obviously then they were monitoring individual cows against milk production and how much they were feeding them. And then obviously in later years, when we had the foot and mouth, they were obviously then able to tag all of that a lot better as well. And seeing the difference in production, the changes in food costs, etc., had quite an impact. So it's an interesting field, metaphorically, as many industries have found as they've moved on into computing. The motor industry obviously has gone from very hands-on, to robots everywhere being controlled by computers. Yeah. And today, of course, we see people like Amazon with their almost staffless warehouses. So
it's incredible. And I remember somebody telling me, again, I think it was in the late 80s, somebody who seemed to speak with authority, saying, well, I think within a year, all the software that could ever be written for a computer will have been written. And that's got tones of when computers, first made headlines. And I think it was, forget his first name. It wasn't Watson. He was CEO of IBM, and he said there's a world market for 6 mainframe computers.
And now we have more than that in one office just for ourselves.
Yeah.
It's amazing how it has gone. So yes. Well, we've spoken a little bit about some of the early computers you worked on. Perhaps just a bit of an idea of the computers and maybe the software languages that have you used over that time, and maybe how the changes in the technology has changed how you program.
Yes. Funny enough, I counted them up a few years ago, and I was thinking about this morning, and I may have missed a few, but there are 17 Turing complete languages that I've learned to one degree or another. I'm not saying I'm fluent in all of them, but over the years, that's the number of programming languages. Because I think anybody who's been in programming for decades, you have to pick up a new language every now and again. Certainly new libraries, new techniques, new ways of thinking, new ways of developing. I mean, one of the languages, I mean, I learned Cecil, Fortran, and then when I was teaching IT for the first time, we had an Osborne computer which was running CPM, but it had a Microsoft. It was way before GW Basic, but it was an early Microsoft interpreter, basic interpreter. And because I'd learned Fortran, I found that very, very easy, because Basic was developed from Fortran as a more of a teaching language. And so I learned Basic very, very quickly, self-taught. But the language that most impressed me after that was Pascal. For the simple reason is I got I was doing an evening class in a local college. I was a student. I was doing a City and Guilds 726, and we did 3 applications, which were word processing, spreadsheets, and databases using WordStar, SuperCalc, and DBase 2.
Yeah.
And then we did 3 programming languages: Basic, which I didn't need. I just did the assignments because I didn't need to go to the classes to learn; Pascal and COBOL. And what amazed me with Turbo Pascal 3 was, unlike COBOL, where you'd have to, after loading up the operating system, a double twinned IBM PC, green screen, you'd have to put in your document editing software, which is quite often WordStar, open a non-document file, create your COBOL program, save it onto the B drive, come out of the word processor, then put the COBOL compiler and runtime in to the A drive, tell it to load the program stored on the B drive, run it. Again, the errors would be directed to the printer, so you'd have printout of all the errors, and then you'd have to look through them. Then you'd have to take out your COBOL runtime and then put in your word processing. Right, what happened with Turbo Pascal was it was the first integrated development environment, Turbo Pascal 3, and it would run on CPM or MS-DOS or PC-DOS. And not only did it have an editor and a compiler, but you could run it from the same environment.
Yeah.
And of course, with Turbo Pascal 4, which was a few years later, you could actually debug it from the same environment. But this Turbo Pascal 3, where you could edit, compile, and run, without touching any disks at all.
Yeah.
I thought, wow, this is brilliant. And not only that, originally it produced a .com executable, which was fantastic because nobody could see your code. Because Basic was brilliant. I love Basic, but of course people could see it, ran an interpreter, so people could see your source code. Pascal created a COM file, so absolutely brilliant. And then of course with Turbo Pascal 4, it created an EXE, which was even better. So that was the first language, and I thought, wow, this is the way forward in creating computer programs.
It's funny, isn't it? Yes, I remember those days. 2 5.25-inch floppy disks,
Yeah.
pushing them in, praying that they hadn't corrupted.
Yes.
And the technology, obviously, now we don't even think about it. In fact, my latest computers, I don't even think have CD drives. So the way the technology, I don't know if the technology has pushed the languages or the requirements of programs have pushed the technology, but
I think it's a loop that they push each other.
yeah. And as you said, but the languages, they've improved, they've expanded. You think nothing now, as you said, of debugging a program in situ, in real time. Not all the time, but in some cases, even with cloud computing, you can get away with that. So yes, and the technologies of development, gone of those one-off programs, as I said, in something like GW Basic, where your program just went down, and if you thought about it, you might use a Go sub. If you did that now, you'd probably be strung up and drawn and quartered. So the technologies as we push forward with object-oriented programming, design patterns.
Yes.
How do you think? Do you think in all that everything's been a good thing? Do you think there's still room for improvement?
What happens is that people realised a good way to program in the 60s. I mean, Dijkstra and Tony Hoare and Worth, they all had brilliant ideas, which has taken some time to actually put into practice. But instead of having a monstrosity breaking up the program into modules, for example, and instead of using go tos or go subs, talking about like GW Basic. The BBC Basic came out with procedures, which I found I love BBC Basic because of that. So I think a lot of there's been a lot of great thinking from a long time ago. Structural program is one. I've got a book called Structural Design on my bookshelf, and it's from the very early 70s, and it's got a massive amount of stuff in there which is so applicable today. And I think what's happened is that over time, a lot of these ideas have been they've been about, and people who write either compilers, interpreters, or development environments have taken up the baton and tried to implement a lot of these ideas. I mean, you talk about OO. Um, OO, the idea of OO came about, I think, in about 67 or 68. But of course, it wasn't until the 1990s, really, that it became mainstream programming. So it took almost 30 years before that happened. I mean, there was OO languages about before then, like C++ came about in the 80s, but it wasn't until the 90s that things started to take off that way. People were quite happy with procedural programming.
Yeah, it's certainly some of my codes. From time to time, I have to stop myself and go, this is getting a bit long and I should rethink it and refactor it back into something more up to date. But it's so easy just to run through.
And that may be having a rebirth, strange enough, because I seen a presentation on YouTube. I can't remember the guy who was doing it, but he compared two implementations of a system that he wanted. It was sort of a prototype, and one he did using OO, and one he did using procedurally. It was graphics.
Yeah.
And the procedural one was 5 times quicker than the OO one.
Yes.
And it just goes to show that you mustn't be blinded by a particular way of thinking. You can't say, oh, everybody does things with OO, so I won't do procedural. I think you've got to pick and choose the best way. And if procedural is the best way of do something, then do it that way. I mean, the reason OO came about was the reuse side of it. But you can still write good procedural code. If you've done OO, you can think like OO, but write it procedurally.
Yeah, I agree. Particularly if it's at least then, and with a lot of modern languages now, is that you can hide sections of your code. So even if it's all in one procedure and you've written lots of functions that you perhaps would have put as a class,
yes,
just say, no, I'll just hide that bit. I know it works. I want it here. And yes, the time of loading everything up, calling it, you lose. Of course, today with the modern PC, do we really care about time or memory? The answer's probably not. Unlike
most
the
of the time
days.
you're right. I think I couldn't put a figure on it, but I would imagine 90% of the time you're absolutely right. We're not interested in that because machines are so quick. But in the few cases where you do need speed, then writing something procedurally may be the solution to it.
I think it is. Wonderful. So I think, what do you think have been the biggest changes to our industry over the years?
Well, one of the biggest ones, I think, has been the uptake of the World Wide Web. I mean, the underlying technology of the internet has been around since the late 60s, but it wasn't until Tim Berners-Lee, thought about sharing information that it really seen its full potential. And just being able to go to a computer, quite often you'll know this better than anybody. You come to a problem, you think, how can I solve this problem? Oh, I'll just go on. Oh yeah, Stack Overflow. Oh, that's how you do it. Right, great. Right, within a few seconds, you've got a solution to a problem. Whereas years ago, if you were working in a team, you could go to another member of the team or ask, or you could try to find something in a book, but it would take you hours or even possibly days to find a solution. You may have to experiment God knows how many times and get it wrong. Now, everything is at your fingertips because of the World Wide Web. So that has got to be one of the greatest inventions of all time.
Yeah, I agree. In fact, I was with Stack Overflow yesterday, writing a program in a language that I don't use a lot of all the time. I knew what I wanted to do. I just wasn't sure of the syntax, and went to the site, and it was Stack Overflow. And he went, "Oh, you can do it this way, but actually there's a better way with a command I didn't know about." So of course you then learn not just
Exactly.
the fact how to do it, but how to do it possibly better.
Yes.
So yeah, internet's wonderful. We've covered some of the sort of things you've done. Is there any stories you'd like to share about your career?
Well, I'll say one thing that quite often you can be surprised that things are not quite what they seem on the surface. I was writing some software for a guy who had a print shop, and we were doing this as a joint venture. It was a print estimating piece of software, and there's quite a lot of requirements involved. I mean, you use different types of materials, so paper, card, and so on and so forth. And that's your sort of your stock that you use, but quite often it's cut down into different sizes. For example, business cards, you'd have a say an A4 cardboard stock, and then you'd want to get as many business cards out of that. So he said, "Oh, on such and such a size, I can get these number of business standard size business cards." But he said sometimes people want slightly different size cards. So part of the requirements is that we need to work out the best way to align these cards on the stock so we can get the most business cards out of that material. And on the surface, you think, oh, it's a fairly simple algorithm to do. And then when you get there, it does your head in. But strangely enough, I managed to work it out in the end, the best algorithm to use. And he was playing around it one day and he said, "You can't get that number of cards on that size stock at that size." And I says, "Well, the software says you can do it." So he tried it out and hey presto. And he said, "Well, I've been at this game 30 years and I never knew you could get one extra card by sorting it out." So it just goes to prove you can be surprised by the most simplest of things.
Yeah, definitely can. And a lot of these people, particularly the older people in the industries, they've, as you said, they've been doing it for 20, 30 years. They know what they're doing. It's the same with the farmer who goes out in the fields every year. He knows what he's doing with his fields. So when you come along and give him something and they go, "What?" It is good. And yes, I think I've had a few of those during the years.
I mean, if you want one other thing I can think of was
Yeah.
design patterns, because
Yes.
I picked up the book by the was it the Gang of Three or Gang of Four, the
Yes.
Amigos as they called them. Um,
Is that the applying UML and patterns book?
yeah,
Yeah. In fact, my copy is within hand's distance.
design patterns by Johnson, Vlasides,
Yeah.
Helm, and Gamma. I've got it on my bookshelf, and I picked it up. Um, I think it came out in the early 90s, but I didn't see it till either the late 90s or perhaps 2000. And I looked at it and I thought, I didn't fully understand it at the time, but I recognized some of the patterns. And I thought, oh, I've been using that pattern for years.
Yes.
And obviously, what the light bulb went on. I thought, well, the reason for that is it's been given a name. So although you know how to do this, for example, the iterator pattern, everybody at some point in time, before using libraries where you got collections and they all come with this stuff, if you go back pre sort of mid-90s, you wrote your own stuff for going over collections. So
Yeah.
you'd have a first, you'd have a last, you'd have a next. And of course, you'd use this time and time again, but you never thought it was called the iterator pattern. And there it is, the iterator pattern. And what are the problems with it? Well, if you're doing an iteration and somebody adds something, there can be a problem because you've lost your index within the collection. So it points out all the problems, all the limitations to it, and then it also gives you ideas of how you can improve it. You could do a reverse iterator. So instead of starting at first and then doing next, you could start at last and do previous. So it gives it really, and then filtered iterators. So you could say, I'm not interested in this particular type of item.
Yeah.
Give me the next one in the filter, in the filtered list. So that is like I don't know, it's like an ABC, and then all of a sudden you think, wow, I can do all these amazing things using this basic pattern. And that was a real eye opener.
It is. Yes, I must admit, I looked at 3 or 4 for towards the back of the book, and I still look at them and go, no, I can't think where I would use them. But as you said, I'd probably use 7 or 8 of them every day without even thinking, not even knowing that that's what they were called. So
Yes.
no, that's brilliant. So what are your thoughts, I suppose, on the profession today, and where do you think it's going to go in the future?
Well, I mean, I think I've got quite a rosy view of the future, because my own feeling is I think software developers are more professional these days than what they were many decades ago. I think, and it's there's lots of reasons for that. I'm not saying the people were bad, but there's so much more information out there now that you can improve your craft, and there's so many frameworks available to you. You don't have to reinvent the wheel. There's so many processes, and I'm a massive fan of agile. So that's really improved the way you do things. I mean, I was involved with agile for the last, I suppose, 13 years of my professional career, and I seen the light almost immediately. I mean, I knew about it before, and I wanted to do. In a previous job in the early 2000s, I had introduced some agile techniques, but it was difficult to go fully agile. But when I went fully agile, I remember I was doing a contract for the Metropolitan Police in London, and they had about 10 teams, all working on different projects, all agilely driven. And we were sitting in a room, and we were getting the views. We were doing some planning poker, where you look at the backlog and you assess the tasks to be done and try to work out how many points this particular task or subtask was going to take. And just getting the views of the product owner, the analyst, the front end developers, the back end developers, the testers, the architect. It's amazing, because quite often you've got a tunnel view of how this should work. And then you listen to all these opinions from different professionals, and you think, wow, that's incredible. I never thought of that way. I'd never seen it that way. And that is one reason I think why agile is so good, if you do it properly, is that you get over some of the problems you'd had before by missing very subtle points, because you see so many different points of view. You can see what some of the gotchas are, and that prevents you going down the wrong route. I'm
It
not saying you
certainly
don't
does.
never go down the wrong route. Sometimes you've got to spike something because you just don't know how to approach it. But many times, just getting a different view from everybody makes a massive difference.
Yes, I think you're right. I think with agile, because you tend to have all the key players, stakeholders, as part of that team, even if it's not their primary role. When you're deciding on the work, they're going, oh, actually, could we have this first? Because they know their priorities, or you can then explain why or what's needed. And also with Agile, the fact that you haven't got 2 years down the line delivered the product and they go, well, we don't do this anymore, and that doesn't really work for us. You've now got it. If not so much a mistake, if a feature is no longer required or isn't required in the same way, you have the opportunity to stop, re-engineer it at that point. You know you've got the commitment beyond it, but you are delivering what they want on time, and it copes with the variations, which is definitely worth it. And it involves you start to learn, particularly as a developer. I worked in a financial institution for many years, and I'm not a finance expert, but I started to learn what they did, why they did, even down to why you have someone who checks whether you've dotted an I or crossed a T for the legal documentation to do with the financial product, because they're part of your team, and it rubs off. You learn the business, which I think is probably more important sometimes than learning our industry.
Well, that is something that is always a challenge when you start with software development in a new company or a new contract. Is it takes you some time to get used to the business domain and work out the rules on what can be done and what can't be done and what should be done and what should not be done.
I sort of asked the question earlier about where do you see it going in the future. I suppose particularly at the moment, because I've noticed in the news there's been issues around AI and robotics, particularly AI. Do you think AI might be a threat to the industry? Do you think it would be a positive to the industry?
Well, one of the things that I'm very interested in is quality software and assessing quality. And this is one area where I don't like the term AI. I think it's a misnomer. But I'm going to put that to one side for the time being. I think self-learning applications are really good, because take, for example, a technique of pair programming.
Yeah.
One of the reasons why that is efficient is because you have two sets of eyes on the code. So the person on the keyboard actually typing the implementation, he's thinking one way, and his partner is looking at it and think, oh, I think he's going down that route. I can think of a better way of doing it. Or he's just made a mistake there. He's used a variable that he hasn't assigned yet a value to. So it's that type of thing where you've got two people, two sets of eyes, and the more sets of eyes you've got on it, the more bugs you can cut out. Now, if you've got an application sitting in the background looking what you're typing, an AI program, it knows all about the language you're using, and it may know something about the business domain as well. And as you're typing, it can make a note. You may not want it to interfere with you. I suppose you could set it up in different ways, but what you could do is at the end of that session, it could say, well, my opinion is you've made a mistake there. You've forgotten to do that there. Really, you should be doing it this way, but there. And that would be a fantastic assistance to a developer.
Yes, I think one of the, not so much AI because it's older than this, is when editors started to lay your code out for you to make it look pretty. It's what you should have done.
Yes.
But of course, a lot of people came out from the environment where having spaces even for commenting code was eating up valuable memory. But now having it so it's not just structuring your code for you, but color coding it so you can follow it. Again, those sort of enhancements and help. And you're right, having someone looking over your shoulder and go, I wouldn't have done it that way. Do I mind if it's a computer? I probably don't. Although, yeah, no, so big, that's quite good.
and those type of applications where they're almost doing a code review dynamically as you're creating the code, I think could be very useful and could help cut out a massive number of mistakes.
Yes, I agree. I said about any threats to the industry. From where I see, my problem is, and the internet is part of the problem, is that you see a lot of people who think they can program, or some who can't program but pretend to be programmers, who are out there hawking for work and then delivering nothing or substandard programming. What are your thoughts around those sort of threats?
I think this is a function of technology, and I think you'll always get it. I mean, some people will. If you go back to the invention of the telephone, people thought it was great. You can speak to somebody over a long distance, and today it's used a lot for scamming people. So you'll always get somebody who will turn technology for to bad purposes, and it's happened with the internet. Cars are great for traveling from A to B, but on the way it can kill another person. So it happened in Berlin, I think last week, wasn't it, where there was pedestrians killed. So any technology, whatever it is, it can be used for bad purposes, and I think the internet is going to do this. There's never going to be a stop to the problem of the internet being used for people who pretend they know something when it's called ultra crepidarianism, I think is the correct name, where you pretend you know something that you have no idea about.
Yeah.
And that type of stuff, there's sure there are some things you can do about it, but there will always be people who say, yeah, I can do that and I can do it at half the price. I mean, you look at any big project, it overruns by 10 years, costs £20 billion more than the budget, and it happens time and time and time again. And will we ever learn?
No.
It's strange. I read an article in New Scientist about China's doing these very small scale nuclear reactors, and they always come in on time and on budget. So they are using some sort of technique which actually works, where they can do the estimates correctly, they can do the implementation correctly, and they get what they want when they want it. But in many situations, we just seem unable, whether it's the Elizabeth line or whether it's Hinkley Point. Things just cost. What I always say with these things, put a note on the end for the price, and then triple the length of time, and you might come somewhere near it.
Yes. Yeah, projects going over budget. We're not very good even with knowing what we're doing.
No.
So that's a good question. Where do you see the role of professional bodies today? And I suppose in that instance, where do you see the role of the IAP?
Well, one of the greatest things about the IAP is that it's an organization, and I don't want to sound snobbish at all, because if anything, I'm an inverted snob, but it does attract the best people, and those people are not just accepted; their credentials are looked at, examined, and it's done in a logical manner, the number of points they've got. So anybody who employs a person who is a member or a fellow of the IAP, they know that they have been looked at, they have been weighed, they have been measured, and they are fit for purpose. And that as you were saying, with a lot of cowboys about, is something that people ought to bear in mind when they are employing somebody to do something, that members of the IAP will be the cream of the crop.
Yeah. Do you think the IAP has anything unique, perhaps over organisations like the BCS?
I think so. The first thing I would say, we are a small and elite. Well, the BCS is quite large, but the other feature that stands out is that we specialize in software development, whereas the BCS is a general computing society or membership body. They'll be interested in all sorts of things. So you'll get people who are interested in hardware, for example. The IAP is quite a narrow field. Anybody involved in producing software. So whether it's an analyst or a programmer, somebody who designs software, testers will fall into that as well. It is software development.
Yeah. And an interesting one. As president of the institution, I suppose, what made you become a council member all those years ago, and obviously now a trustee?
Well, the IAP in the 90s had a lovely newsletter called the IAP, which you also put out every now and again. And I used to read the articles in the IAPTUS, and it used to inspire me. Some of the stuff I read there. This was before I had the internet or the World Wide Web available, and to see these articles about programming was fantastic. And in one of the issues of IAPTUS, they said, "Oh, we are looking for people to join the council," and obviously myself and David Morgan seen this advert within the IAP, and we both applied and eventually were co-opted onto the council.
Yeah, I seem to remember myself being mugged by Mike Ryan, who said, "Why don't you come along, join the council?" But it
Well, we
seems
used to see you at a lot of the symposiums before you joined, and I remember chatting to you, so I knew you before you actually joined the council.
this is it. I was, again, like yourself, it was there. I quite enjoyed what the things they were doing. The symposiums, I suppose in those days, there weren't many ways to meet other programmers unless you worked with them. And I think I was working in local government then, and recognised at the time also that it might help me with my career, which it did in the longer term. Just having that little flag you can wave and going, "I'm a member of the IAP," might get you up the list a little bit when it comes to interviews. And yes, I enjoyed the symposiums. They were meeting interesting people, the speakers, and over the years, I think we've had some very interesting speakers. I know with COVID, we've sort of had a bit of a pause at the moment because people are still a little wary. But we obviously have our webinars program, which in some ways has been more successful than the symposiums.
Well,
Yeah.
I think they're more convenient because people can. It's easier to attend, and in some ways, I don't know why that this should be. I think they are more um, they're more apt because I think they're more focused. We used to have really interesting speakers. I remember Trevor Bayliss, the inventor of the clockwork radio, and he was very entertaining, and some of the stuff that he'd had to overcome was great. But we used to have those type of subjects, which is interesting. But the ones we have with webinars are very focused, I think, on software development.
Yeah, I agree. And we have members obviously who used to attend the symposiums. I remember we had somebody flew over from Switzerland. They came for a few days, and I think we had one lady from one of the big banks in France who literally flew over on the morning flight, did the symposium, and even before lunch was back on a plane back to France to her job. Whereas now we have members who are signing on from Africa,
Yes.
Hong Kong, Canada, and America.
Yeah.
We're not perhaps getting more people, but we, as I said, we are opening up much more to our membership generally, and of course non-members who wish to come. So no, I think that's been really good. I suppose, and finally, I suppose, anything else you'd like to say about the last 70 years, sorry, 50 years of the IAP, or the last 70 years of the Queen on the throne? I might re-edit this slightly. Certainly, have you got anything on the last 50 years of the IAP?
Well, if you go back to 1972, which was 4 years from when I started programming, there's been an absolute massive change in software development, and I think the change has been for the better. I think that people's horizons have broadened, and even been extended. The things that you can do with computers would never have been thought about in 1972. And the other thing, of course, it's become ubiquitous. Whereas if you go back to 1972, most computing was done on mainframes. There would have been a few mini computers about, and it was about that time that microcomputers were being thought about. But these days, people don't even think about it. Most people use a smartphone, which has got many times the computing power of most probably a mainframe from those days. They're using apps, which a lot of them are free or come with a phone. They're interacting with remote systems when they do their banking, or they pay for something with their smartphones. They don't even think about it. But it's all, it all involves computing and software at some point. Even, when people are sleeping and things are happening concerning them, it's often driven by software. So it doesn't matter what you do, software is around you and you depend upon it.
I agree. I remember when I first started, the company I worked for, we sold mainframes, and a mainframe then was what, £1 million?
Yeah.
And we wrote a company that we were doing at the time, a food wholesaling company and retail company, and we wrote them a stock control and order processing and invoicing system. And I think that cost them £250,000 for that system, which didn't work the first time, but that's a different story. And now, as you said, you can pick up your phone, you can download Sage or something like that, and it will do all your invoicing for you. You can do your stock control for you. It will do your VAT, your tax. It will send the invoices out and connect to your bank account.
Yeah.
And you might have to pay £10 a month.
Yeah.
And your phone costs you £1,000 if you're unlucky.
And if you go home and sit in front of your desktop computer and open up the same application, you'll see the same data.
It is
because that's the beauty of cloud computing these days.
It is, and even as a computing professional, the simple things. It's like I open my Google account on my phone or on my personal laptop.
It's got the searches that you've used on your desktop.
Tablet, that's it. Or I open it up even within the institution's computer. Suddenly, everything I've got is there. I'm not having to go and copy it across, save it somewhere. I do think, we have seen great strides in the last 50 years. I'd even say in the last 40, since I sort of got into this in the mid-late 70s. Again, like yourself, building something with flashing LEDs in binary. And here we are now, and I can see the technology running away. And equally, I'm still writing programs. I expect you probably still writing something. And it's not necessarily in the languages that I learned 30,
No.
40 years ago. The same underlying techniques, thoughts are still carried forward, and they've been, as you said, added to with classes and being able to create your own, even your own frameworks with everything in, and then everything's just improved. You've added the skill set, and if you move from one language to another, it's usually that annoying comma or colon that is the thing that trips you up. Thank you, Paul.
It's been a pleasure, John, as always.